In this video, I'm going to talk about high availability network services. Actually, in this video, we will learn about the design of network services in the access layer. Okay, first, let me to explain about the redundancy models, and after that, we can explain about each of them with more detail. You know that when designing a network topology for a customer who has critical systems or services or network paths, you should determine the likelihood that these components will fail and design redundancy where necessary. Consider incorporating one of the following types of redundancy into your design. First, workstation to router redundancy in the building access layer. Second, server redundancy in the data center. Or third, route redundancy within and between network component. And also the fourth, link media redundancy in the access layer. Actually, here you can see some of the methods of the redundancy that we can implement: workstation to router, server redundancy, route redundancy, and also link media redundancy. You know that in previous video we learned about the first hop redundancy for LAN high availability. For first hop redundancy for LAN high availability, several protocols increase the ability of a workstation to reach its default gateway router on its network segment. Include the following: hot standby router protocol or Hsrp, virtual router redundancy protocol or Vrrp, and also gateway load balancing protocol or Glbp. Also, I want to explain about the virtual switching system that we learned about it previously with more detail. First, before talking about the VSS or virtual switching system, I am going to review the Hsrp, Vrrp, and Glbp that we learned in the previous video, and after that I will talk about the VSS or virtual switching system. You know that Cisco Hot Standby Router Protocol or Hsrp provide a way for an IP workstation that support only one default router to keep communicating on the internet network even if its default router becomes unavailable. Hsrp works by creating a virtual router that has its own IP and MAC address, and the workstation use this virtual IP address as their default router. I explained it before, but here I want to show you again. For example, between these two router, okay, we will have one group, okay, and here actually we have one virtual router. This virtual router has one IP address. For example, virtual IP is 192.168.1.1/24, and also it will have one MAC address, virtual MAC address, and we use this IP address as the gateway of the workstation in this LAN. Hsrp routers on a LAN communicate among themselves to designate two routers as active and standby. Okay, actually one of them is the active and other is the standby. The active router sends periodic hello message. The other Hsrp router listen for the hello message. If the active router fails and the other Hsrp router stop receiving hello message, the standby router takes over and becomes the active router, because the new active router assumes both the phantom's IP and MAC address, means virtual IP and MAC address. And note, see no change. Okay, they continue to send packets to the phantoms or virtual router MAC address, and the new active router delivers those packets. The default Hsrp timers are 3 seconds for the hello timer and 10 seconds for the dead timer. You can achieve subsequent failover with Hsrp by setting the hello timer to, for example, 200 milliseconds and the dead timer to 750 milliseconds. It is recommended to configure Hsrp with preemption. With preemption, the primary Hsrp router reassumes the primary role when it comes back online, and Hsrp preemption should be explicitly configured because by default it is disabled. Hsrp does not support load sharing as part of the protocol specification. In order to use both uplink paths to the distribution switch, different Hsrp groups are configured for different VLANs, with the primary router configured for switch A for some VLANs and the primary router configured for switch B, or router B means the MLS B, okay, for other VLANs. Hsrp has a native interface trunking mechanisms that is used to trunk an uplink. If the uplink fails, the Hsrp priority is reduced. Hsrp also works for proxy ARP. When an active Hsrp router receives an ARP request for node that is not on the local segment, the router replies with the phantom router's MAC address instead of its own. If the router that originally sent the ARP reply later loses its connection, the new active router can still deliver the traffic. Okay, in this figure we have these sequences. Actually, the following sequences occur. Step 1, the workstation is configured to use the phantom router 192.168.1.1 as its default router. Upon booting, the router elects router A. Okay, for example, this router as the Hsrp active router. The active router does the work for the Hsrp phantom, and router B is the Hsrp standby router. When the workstation sends an ARP frame to find its default router, router A responds with the phantom's router's MAC address, and if a router A goes offline, router B takes over as the active router and continues the delivery of the workstation's packet. The change is transparent to the workstation. The next protocol is the Vrrp, or Virtual Router Redundancy Protocol. Actually, Vrrp is a router redundancy protocol defined in RFC 3768. Vrrp version 2 only support IPv4, and RFC 5798 defines Vrrp version 3 for both IPv4 and IPv6 networks. Vrrp is based on Cisco's Hsrp, but it is not compatible with it. Vrrp specifies an election protocol that dynamically assigns responsibilities for a virtual router to use to one of the Vrrp router on a LAN. The Vrrp router controlling the IP addresses associated with the virtual router is called the master, and it forwards packets sent to these IP addresses. The election process provides dynamic failover in the forwarding responsibility in the event that the master becomes unavailable. This allows any of the virtual router IP addresses on the LAN to be used as the default first hop router by the end host. The virtual router backup assumes the forwarding responsibility for the virtual router if the master fails. The default Vrrp hello timer is 1 second and the dead timer is 3 seconds. Unlike in Hsrp, Vrrp preemption is enabled by default, and similar to Hsrp, to configure load balancing, different Vrrp groups are configured for different VLANs, and Vrrp can also be configured to track the uplink to decrement the Vrrp priority of the primary router. You know that we are reviewing because I explained all of these details in the previous video. Now let me to explain about the Glbp. Gateway Load Balancing Protocol, or Glbp, is a Cisco proprietary Hsrp that allows packet load sharing among a group of routers. Glbp protects data traffic from a failed router or circuit such as Hsrp while allowing packet load sharing between a group of redundant routers. Methods for load balancing with Hsrp and Vrrp work with small networks, but Glbp automatically allows for first hop load balancing or on larger networks. Okay, unlike Hsrp, Glbp provides for load balancing between multiple redundant routers up to 4 gateways in a Glbp group. It balances the load by using a single virtual IP address and multiple virtual MAC addresses. All the hosts are configured with the same virtual IP